If you look at your whiteboard screen, you should see a picture up there. I want to see if you can figure out what's going on in that picture. Don't write it, just think about it for a minute. Okay, well, welcome to week 2 of week 2 of Solar System Learning Lab. I am super excited to be here today and be teaching you guys. We are going to get started. Just a quick reminder to everybody that we are videotaping this lesson. So if you choose to be on camera, your video will be in our class site. We are going to get started today by looking at a picture that is on your whiteboard screen. It's a picture of a person. Now this person is somewhere specific. You may want to make your whiteboard screen larger. The whiteboard screen is the bottom right-hand screen. So reminder on how to do that is there's a purple toolbar right above your whiteboard. Go ahead and click that to make it larger. It will make me go away. And it says underneath the picture, what is this person doing? I want you to think about it for a second. Think about what class we're in. Montgomery, do you have a guess? What is the person in this picture doing?
To be an astronaut.
Very, very close. She's not training to be an astronaut. She actually is an astronaut. Where might she be? She is an astronaut. And she is somewhere. Anyone want to take a guess as to where this person is or where this astronaut is? All right, Alexandria, take a guess. You are correct. She is in space. Carlisle, any guess as to more specifically where she may be or what she may be trying to do?
She's on the International Space Station, laying down currently.
Perfect. She is an astronaut in space in the International Space Station, and she actually is laying in her bed. Okay, the green, what appears to be a green suit that she has on with her arms sticking out of it is actually the sleeping bag that the astronauts sleep in or stand in on the International Space Station. So great job on that. What I'm going to do throughout the course is put pictures up to start with that you may have no idea what they are. You may get lucky and be able to guess what they are. But today we are going to talk about space and how scientists and how we can explore space. But before we do that, I would love to go over your homework assignments from last week. So to those of you who turned them in, awesome. Most of you were able to figure out how to submit them in Moodle. A few of you emailed them to me, which is fine. If I got them, I responded to you this morning with a grade. So let's take a look at the assignments that you guys turned in. They're up on the PowerPoint screen. The top right one, if you could go ahead and make it larger. And what I would love if you guys would share your projects with us. So this first one is Mohammed. And unfortunately, Mohammed is sick today, so he is not going to be joining us. So I am going to go ahead and share his for him. If you guys don't have a microphone, I can go ahead and share yours as well. Or if you really don't want to talk, I can share yours as well. Carlisle, you have a question?
I want to share mine myself.
Okay, fantastic. I'm just going to go right in the order that they are loaded up here. So when we get to yours, you certainly can share yours. So Mohammed did Sir Isaac Newton. He included a picture here. Sir Isaac Newton was a scientist, mathematician, and an astronomer. He is famous for discovering gravity, the laws of motion, and inventing the reflecting telescope. Sophie, yours is next. Would you like to share yours with us? Sophie did Galileo. She wrote Galileo made improvements to the telescope so that it could be used to study planets and stars. Through the telescope, he made the discovery of 4 large moons around Jupiter named Galilean moons. He also discovered sunspots and that the moon has craters. Next is Montgomery's. Montgomery, would you like to share yours? Oh, I'm taking that face as a no. Montgomery wrote, while it may or may not be true about the legend of the apple falling from a tree onto Newton's head, he understood that the orbit of the moon around the Earth is due to the gravitational force. The moon orbits around the Earth due to the acceleration of gravity because of its change in velocity. Sir Isaac Newton also invented the reflecting telescope, a ground mirror and tube, because he was upset by the telescopes during the time he was alive. Instead of using lenses, a mirror was used. This gave a sharper image for viewing. Next is Alexandria's. Now, Alexandria's microphone is not working today, so I will go ahead and read hers. The father of modern observational astronomy, also known as Galileo Galilei. Galileo was an astronomer, physicist, and mathematician, and is famous for discovering and inventing scientific tools we use today. Galileo modified the invention of the telescope by making the lenses larger to 30x to help us get a closer look at the solar system. Galileo invented the thermometer, which helps tell the temperature, and the compass to help guide us with direction. Galileo also discovered Jupiter's 4 largest satellite moons, Io, Callisto, Europa, and Ganymede. These 4 moons were later named Galilea, after Galileo. Next is Carlisle's. Carlisle, you said you wanted to share, so go right ahead.
My report on Galileo. Galileo was an Italian physicist who lived during the 1500s. He was different from other scientists in the way that of his time, because instead of simply philosophizing about his theories and ideas, she used experiments to test them. Some of Galileo's discoveries upset other scientists at his time because he questioned some of their current theories. Some of Galileo's most known discoveries: the principle of the pendulum, the theory that stated that 2 pendulums of the exact same length would swing at the exact same time. This discovery eventually led to the add-on of pendulums into clocks so that the time can be measured in seconds. Theory of falling objects. This theory was a really big discovery because it helped people to understand that 2 objects, no matter what their size, would fall at the same rate. Galileo determined that it was air resistance, not size, that contributed to any differences in time. It was this theory that led to the invention of the formula for determining speed. Speed equals distance over time. This is the equation that is still used in physics today to measure the speed of an object based on the distance it travels and the time it takes to travel. Galileo made an important discovery about a 45-degree angle. The discovery found that an object launched at a 45-degree angle would travel further than if launched from any other potential angle. I would think this was a very important discovery at the time because cannons were used in battle a lot, and to know that the trajectory of the cannonball can be controlled by adjusting the launching angle was probably very important knowledge. Galileo was one of the first scientists to use a telescope for astronomical use. Up until that time, most telescopes were used for sea, but Galileo began to discover the possibilities of discovering the cosmos with telescopes. That eventually opened up an entirely new use for them. So I think that it was very unfortunate that Galileo spent most of his life under the house arrest for voicing opinions and ideas that upset others. Because later on, after he died, it was discovered that he was correct in his way of thinking about many things. It's tragic that such a brilliant scientist never got to see his gigantic impact on his theories had on the world of science. My sources for this report: Wikipedia website, Exploring the World Physics, my current physics textbook, by John Hudson Tyner.
Awesome. Great job, Carlisle. Thank you for sharing with us. Next was Chase's. Chase, would you like to share yours with us? All right, Chase wrote about Sir Isaac Newton. And he wrote, "Truly Newton, not the cookie." Sir Isaac Newton, a name synonymous with apples and gravity. Today we will be speaking about the contributions to astronomy made by the late, great Sir Isaac Newton. While most know Newton for his discovery of gravity, he also invented calculus. It would be wise to start with his laws. First law: objects move at the same velocity unless an outside force acts upon it. Thus, an object sitting on a table remains on the table until a force, the push of a hand or gravity, acts upon it. Similarly, an object travels at the same speed unless it interacts with another force, such as friction. Second law: the force acting on an object is equal to the object's mass times the acceleration it undergoes. Third law: for every action in nature, there is an equal and opposite reaction. If one body applies a force on a second, then the second body exerts a force of the same strength on the first, in the opposite direction. These laws help scientists understand more about the motion of planets in the solar system and of the moon around Earth. These discoveries represented a huge leap forward for the fields of math, physics, astronomy, for calculations that are more accurately modeled the behavior of the universe than ever before. So great job on your projects, guys. I would love for you guys to present them sometime. But fantastic job on your first projects. If you turned your assignment in you received a passing grade. Just a reminder, this is a class that is meant to be an extra class, so I am not giving grades in terms of A, B, C, D, F. You are just going to get participation grades for coming to class and doing the assignments. So that kind of closes up last week where we talked about famous astronomers, and now we're going to get started with this week, and we are going to get started by talking about and hopefully understanding modern science exploration. So on your PowerPoint screen, you should see a telescope. Here's a couple of pictures of different telescopes. It says telescopes are a tool that scientists use to study space. They were one of the first tools that scientists used to study space. A telescope collects light with a mirror or a lens to make distant objects look clearer or brighter. Today, we are going to make, hopefully, a very simple telescope. An observatory that can be seen in this picture is a huge telescope. There are several observatories in the U.S., and an observatory is a large house for a large telescope. Usually, they are built far away from city lights and pollution so that the images are clear. Now, telescopes and, a telescope you might have at home and a telescope in an observatory have to look through the Earth's atmosphere into space so that it can view things. If the telescope is in a neighborhood or in a city with lots of lights, or light pollution as it's called, it can be very hard to see through the telescope. So you are best off using a telescope on a clear night that's not cloudy and in a very dark spot, the middle of a field, the middle of anywhere where there are not lights. Now, the Hubble Space Telescope is a different type of telescope. The Hubble Space Telescope is a telescope in space. So this Hubble telescope does not need to worry about looking through light pollution. It is already in space. It was launched into orbit in 1990. It's been repaired a few times, and it can take much clearer images. Radio telescopes are another type of telescope. They have an enormous metal dish that you can see in the picture on the left that picks up radio waves emitted by distant stars in faraway galaxies. Now, if you look at the image on the right, you can see a comparison between an image from a radio telescope and an image from the Hubble telescope, which is a light telescope. The radio telescope is up on the top, and it's much blurrier, but it can see images that are much farther away. The visible telescope sends a much clearer picture, but what it is looking at needs to be much closer. Those are all ways to look at space either from Earth or by using the Hubble telescope using a computer from Earth. But another way to look at space is to travel to space. rockets were first used to launch other spacecrafts. And then space shuttles were used. Space shuttles were the first spacecrafts that could take off from Earth into space and return to Earth and be used repeatedly. So it could do a mission now, and it could do another mission in a year. And the ultimate lab in space is the space station. Here's a picture of the space station. In the center, you see the living quarters of the space station. All around the outside, those are solar panels that are used to power the space station. And the space station is a home in space that orbits the Earth, has living quarters and labs for space studies. Now I have some facts here about the space station. The International Space Station, which is what this is called, was launched in 1998. And it is expected to be operational through at least 2020, so for at least another 5 years. It can support up to 6 people at a time living there, plus some visitors. That's 6 full-time people. There's laboratories and sleeping quarters, kitchens and bathrooms. Astronauts can go outside of the International Space Station through airlocks or special doorways that open to the outside. The International Space Station has docking stations that allow other space shuttles to connect to the space station. Now, why do you guys think you may need to have other space shuttles attached to the space station? Victoria, why do you think?
Hear me? Can you hear me? Okay. Maybe if they needed a repair for another ship, or they needed more, I don't know, like fuel to power their ship, or to come on to... my words are not coming to my mouth. They... to talk to each other about the discoveries maybe they have made. Yeah.
Okay, so you said, I believe in the beginning you said something about to come to make repairs. That is certainly a reason why another space shuttle may need to attach to the space station. Carlisle, I think you had your hand up. Did you have a thought?
Yes, I did have a thought, and it was, well, to transport crew to the space station, back and forth from the ground to the space station, and also to come in and repair, like she said, like Victoria said.
Very good. Repair again, that's a great one. And bring supplies. Very good. They definitely need some supplies on the space station. They need supplies for the labs or the experiments they're trying to do, and they also need supplies to live. They need food, they need water, they need things brought to them. They also need to change out the astronauts in the space station. While the astronauts do live there, they are not meant to be there indefinitely. So they do change out the astronauts that are on the space station. Anyone else have any ideas? All right, great job. So the International Space Station is a manned way to explore space. There's people on the space station. There are also times when you want an unmanned station. So for example, those are space probes. An orbiter is a type of space probe that travels around a planet examining its atmosphere and surface. A lander touches down on the surface of a planet and sometimes can carry a robot to explore a small area. And a flyby probe flies past many planets and moons and space objects, sending photos back to NASA or to the other agencies that it is working with. The last type of technology used to study space is artificial satellites. Artificial satellites are a machine that circles the Earth. Instead of looking out at what is in space, artificial satellites are normally turned to look back at the Earth. They are a machine that circles the Earth. They are used for spotting hurricanes, studying the Earth's surface, sending television programs around the world, and for different types of communication. So we're going to take a quick look at the past, present, and future of space exploration. Does anyone want to read this slide? If you do, just go ahead and raise your hand. Victoria, go ahead.
Space exploration, the big picture. Space exploration is still in fancy. Although we have learned a lot, we still have a lot of questions. The cost of space exploration mandates that we work together with other countries. Example, International Space Station, ISS.
Thank you very much. So NASA is the National Aeronautics and Space Administration. It is the U.S.'s space section or space group. Their accomplishments were first to land someone on the moon. They invented the space shuttle. And they developed many products for space that we now use as everyday products. One of these is Velcro. So why are we so curious about space? We are curious and we do want to study space. Things that we need to know about space exploration include everything on this list: rockets, satellites, probes, space stations, remote sensing devices, spacesuits, radar, computers, fuel sources, landing modules, materials that can survive extreme heat and pressure, solar panels, living quarters, biomedical equipment, air purification devices, telescopes, and many, many more. So the history, the past of space exploration. Anyone want to read this one? Go ahead, Victoria.
Space exploration history. The space age began on October 4th, 1957, when the Soviet Union launched Sputnik, the first artificial satellite to orbit Earth. The Soviets also achieved the first piloted spaceflight on April 12, 1961. The first cosmonaut was Yuri Gagarin. He orbited Earth in a ship named Vostok.
Very good. A cosmonaut is the Soviet Union's version of an astronaut. It's the same thing. So the Soviet Union sort of started space exploration. And then the U.S. joined in and decided we wanted to go to the moon. So we sent Apollo 8, which orbited the moon 10 times and returned to Earth on December 21st, 1968. Then we sent Neil Armstrong and Buzz Aldrin, who landed Apollo 11 on the moon on July 20th, 1969. And Neil Armstrong was the first person to ever set foot on the moon. Now, a neat little fact, the laptop that you're using right now, or the computer you're using, or the laptop in a typical U.S. classroom, is more powerful than the computers that were used to run the Apollo program and send Neil Armstrong and Buzz Aldrin to the moon. That's a neat little fact. Okay, so what would be, we talked about probes, space probes a little bit a couple minutes ago, and space shuttles that are piloted by humans. What do you think some advantages or disadvantages are of probes over human piloted ships? What would be some comparisons between the two? Anyone have any ideas? What would make either a space probe better or worse than a spaceship piloted by humans? Carlisle, go ahead.
Well, for one thing, you wouldn't have to worry about the survival systems needed for a manned space mission.
Very good. You wouldn't have to worry about humans surviving. Anyone else? Victoria, go ahead.
Well, let's say if the probes went on space and something happened, they're only programmed to do what they can, and they wouldn't be able to, well, maybe they would, but they wouldn't be able to repair themselves. But unlike the human pilot, they could get in contact with the space station through radio, and they could make changes because they were not programmed to do something.
Good job. The probes aren't able to self-fix themselves most of the time, so the human piloted have an advantage there. Good job. Probes can also make spaceflight cheaper, safer, and faster. But human pilots can make decisions when things don't go as planned. So we need to use both to explore space, and NASA and other space agencies are trying to find out what that delicate balance is between using probes and using humans. So the future of space exploration, I put a picture of the Jetsons up here. Some of you may have seen that cartoon before, some of you may not. Exploration for the future of space has astronauts going to greater distances, staying in space longer, and humans need to be ready and educated for the space travel of the future. Some difficulties in space travel and what is limiting space travel right now is the amount of radiation exposure, lunar dust, which is very fine, getting the proper food and nutrition while astronauts are in space, exercising, the different pressure and atmospheric composition and gravity levels in space, a lack of sleep, risk of bone fractures and reduced muscle mass, reduced aerobic capacity, the lungs of astronauts shrink over time, and then mental disorders arising from extreme confined and isolated conditions. So those are some of the problems facing astronauts and space exploration. Now, we cannot go into space today, but we are going to build a telescope for 2 reasons. Victoria, you have a question?
Well, kinda. Also, another difficulty would be that, let's say you wanted to go farther into space, it would take a very long time because just going to, I think, the moon takes, I don't know how long, but going to, let's say, Mars or somewhere else would be over 9 months or a year, and it would be a very, very, very long time.
Exactly. Going to planets far away definitely take a long time and are very expensive, and you need lots of fuel to be able to do that. So, we are not going to space today. We're not launching up in our space shuttles. We are going to create a telescope that hopefully will allow you to understand the idea behind telescopes. Now, I know you're not going to be able to take this telescope out and see the craters on the moon with it, but you will be able to get the idea behind a telescope. So if you read your syllabus, you should have some supplies handy today. Okay, those supplies are 2 magnifying glasses, a cardboard tube, some sort of tape, a ruler, scissors, and a piece of plain paper with print on it. Okay. Now, we are going to make a makeshift telescope. If you do not have your supplies with you, just follow along with me. I will put the directions up on the Moodle site if you would like to try later. So what we are going to do is you are first going to take your 2 magnifying glasses. Now I cut mine out of the little hoops. You do not need to. You are going to hold one of your magnifying glasses between you and a piece of paper. So you're going to hold it like this so that you can see the print. The image on the paper will look a little bit blurry. Should. Now you are going to take your second magnifying glass and put it between your eye and the first glass and see when the print becomes clearer. You are going to ask a friend, a parent, your brother or sister, to measure the distance between those 2 lenses. Now, I have already measured mine. You're measuring the distance between the lenses where the print you are looking at is the clearest. And you're going to write that down. once you've done that, answer the question here. You're going to click yes when you have made the measurement. Now, if you are not doing this activity with me, just go ahead and click yes so that we are not waiting for you. Okay, we're just waiting for one more person. Okay, well, while Carlisle is waiting, what I would like the rest of you to do is take your cardboard tube, measure an inch from one of the ends, and cut a slit in your cardboard tube. Please be careful you don't cut your hand. Okay, so you are going to make a slit in your tube. The slit needs to be big enough for your lens of your magnifying glass to be placed in it. Next, you are going to measure the distance that you wrote down. So mine was 5.5 inches. So I'm going to put my ruler at the slit and measure 5.5 inches and cut another slit. Depending on the strength of your magnifying glasses, your distance may be more or less than mine. So now you should have your tube with 2 slats or slits cut in it. Then go ahead and answer the page for me. You now are going to take your magnifying glasses and slide them right into the holes. They may sit nicely. You may need to tape them there. My first one fits nicely. My second one needs the tape. Now, if you want, you can trim the end here so you don't have so much excess. I'm going to trim mine a little. You should leave at least an inch from your magnifying glass to the end of your tube. And now, if you look at the outside of your tube, you see the two slits with the magnifying glasses in it. And if you look through your tube at something printed, you should be able to get your image to be more in focus and crisper than looking just through your eye. So go ahead and give that a try. Take a look at a printed page, and then take a look at something either across a room or out a window. You're going to need to either squint your other eye closed or cover it with your hand so you are only looking out of one eye. If anyone wants to share some observations that they can make while looking through your make-at-home telescope versus looking with your normal eyesight. Montgomery, go right ahead.
I couldn't hear you a bit. First time I couldn't hear you a bit. For a minute.
Oh, okay. I'm just asking if anyone wants to share any observations that they can make through their telescope versus through their regular eye with me.
It was slightly magnified, and it was a lot more crisp. To me, when you showed, it kind of was the same, almost like my reading glasses that were magnified, and they just looked a lot, I don't know what the word is for it, but it was definitely a lot more crisp and clean, and you could tell for each word and each letter or something like that.
Very good. It definitely makes the images much cleaner or crisper. So if you didn't have the supplies today, go ahead and try it at home after class when you get the supplies. The stronger the lens of the magnifying glass you use, the stronger telescope you will have in the end. And you can use that to try to look outside tonight or on another clear night and see if it makes any of the stars any clearer. Now, since we cannot go out to space, and we did our little telescope activity, now we are going to take a look at a video of the International Space Station. What I would like you to pay attention to is what can be found in the images that you see on the International Space Station. The video is I'm going to shut my video off, and the video is going to play on the PowerPoint screen. So you should now see the video. You may need to scroll up or down a little bit, and I'm going to go ahead and start it. All right, so hopefully you guys got a little bit of a feel for what the International Space Station looks like. It showed you some video of the actual space station with the huge solar panels and the inside different living quarters, as well as the views from the International Space Station. Now, I, for one, think it would be pretty cool to go up to the International Space Station, but I know that that is not a viable possibility anytime in the near future for me. But maybe for you guys, one of you, some of you, it may be. Now, the International Space Station took lots of planning, lots of years of collaboration between different countries, between different groups of people, in order to become a reality. You do not have years and years. You have 1 week to come up with an object that's going to go into space. Now, your homework assignment for this week is obviously not to build something that is going to get launched into space. But it is going to be to come up with and create an object that can be used to study space. Your object may be a telescope, it may be a space station, a satellite, a probe, or something completely original. I would like you to include either a drawing or a model of your object. Let's say you really like to do Lego or the Connect things. You can make a model out of that and send me a picture, or you can draw a model on a piece of paper. And I want you to tell me 5 key features of your object that will allow it to exist in space. So for example, if I create a space probe to study the sun, I'm going to make my drawing, and then I need to come up with 5 features that allow my space probes to exist in space. So I'm going to give you some examples on the whiteboard. So my first feature may be it uses solar panels for a power source. Now I'm going to need to include those solar panels in my drawing. My second feature may be it uses a non-manned probe, so it can land on the sun without risk to human life. I may also write it uses fire retardant materials to resist the sun's heat. And then I would come up with a number 4 and a number 5. And I would include a drawing of my space probe. And I may include labels, so let me say that these are my solar panels. And maybe over here, I have a camera. And you are going to create an object, something that can go into space to explore space. It can be as technical as you want. You can go ahead and look on the internet for ideas, but please don't copy something right off of the internet. Does anyone have any questions on your homework assignment for this week? All right, well, same thing. Your homework is going to be due by 9 o'clock on 9 a.m. next Thursday, so I can look at them. We're going to share our assignments again in the beginning of class. And if you make a model, save it, because then I can turn your camera on and you can give us kind of a 3D tour of your model. Yes, if you want it to be biological, it certainly can, Chase. Great idea.